Hi everyone, welcome back to my channel. In this video, today we'll be discussing divisibility problem on DFA construction. My first question to you people, have you ever struggled with DFA problems where we need to track multiple conditions at the same time? That means like one condition for the number of A's and another for the number of B's. So you might have solved some of the problems, very direct questions, but in this case there are two conditions. We need to track both A's and B's. At the same time, you have to satisfy the condition of divisibility. Well, in today's video, I'm going to show you step by step how to solve one of the most important DFA mode problems. Okay, so in this we need to construct. All right, let's begin with the problem statement. Construct a DFA. Construct a DFA to accept string or a comma b's whose the number is a is divisible by 5 and the number of b's is divisible by 3. This means our DFA must satisfy simultaneously keep track of both A's and B's using modulo arithmetic. So in this we have to analyze the problem. For first condition you have to keep track of a mode 5. That means you keep track of number of A's. So this will give us, to solve this, first let's track the count of A's. We'll use a modulo 5 because we want to divisible by 5. So that state will be based on reminders. Based on the reminders. Let us find the reminders for A. Suppose if I take a 0 mode 5, we'll get the 0 reminder. 1 mode 5 will get 1 mode reminder is 1. 2 mode 5 will get 2 reminder. 3 mode 5 you will get 3 reminder, and 4 mode 5 you will get 4 reminder. So when you try to divide 5 mode 5 you will get reminder 0. So rest of the number, if you keep on dividing by 5, you will get the same reminders 0 to 4. So you have to stop it. We call this, so you have to stop this. Okay, that gives the, so which this reminder will treat them as a state of a DFA for keeping a counting of A's. Let's see, another condition is that you have to keep track of number of B's using divisible by 3, which you can similarly for A. So there is 0 mode 3 which gives 0 reminder, 1 mode 3 which gives 1 reminder, 2 mode 3 which gives 2 reminder, then 3 mode 3 will get 0 reminder. Again, if I keep dividing by 3 in the remaining numbers, we will get the same reminder 0, 1, 2. This will fix the number of state for B's. Number of B's. Look at this. These are the state, 5 reminders, will give the 5 states. Here it is 3 reminder, you will get the 3 states. So now here comes the interesting part. We need to combine both the condition. How do you do that? We take the Cartesian product of the two sets. There are two reminders, set 1 and set 2. If I take the Cartesian product of these two, that means you have 5 state in this. You have 5 state, right? You have 5 state. Then this will be 3 state. We'll get 15 state pair. 15 state if you combine these two. So now how to make the Cartesian product? So that means 0 versus 0, 0 versus 1, 0 versus 2, okay, 1 versus 0, 1 versus 1, 2 versus 2. So like that you can make a pair, right? So there is, you can make a pair, right? So there is a, I'll show you how to make the pair of state, okay? Similarly, 0, 0 versus 0, 0, 1, 0, 2. Similarly, 1, 0, 1, 1 and 2 and so on like that. So 15 pair of state you will get. 15 pair of state you will get. Okay. So I hope you understand this concept. How to find out the number of state for A, how to find out the number of states for B, and you make the combination of these two condition by using a Cartesian product to find out the number of states. Totally we have 15 states which can represent this problem, right? Let us move on to the construction of transition diagram. We have already paired the states. We'll take up them into this. So we have 0, 0, 1, 1 and 0, 2. And that's how you have to solve the DFA problem where you need to track two different modulo condition at once. If you found this explanation helpful to, now you will let us try to construct the DFA. Right. So 0, 0, 0, 1, 0, 2. First you have to write 0, 0, 0, 0. Okay. So I'll take the condition is here 0, 0 which is initial state. On B I'll take the B. Okay. 0, 1, 0, 2. Like that you have to take all this. You'll take this 0, 0, 0, 1, 0, 2 on linear combination which accept a 3 number which is divisible by 3. This is then which is the final state. Final state is a 0, 0, 1, 0, 0. Similarly, for you can look at it for other condition is number of B's, right? So there are 5 A's, right? 4 A's are there. Again, you have to coming back on A to the final state which also accepted. So there is phi of 3 A's and 5 A's will be accepting which is divisible by both the condition which are satisfied. Why do you make the 0, 0 as the final state which satisfy both the condition even if you divisible by 3 or 5? So that's a reason we have taken that as a initial state as a final state. So there may be other condition and also it will be some of the rejecting state will come for combination of this. Rest of the pair of state have to be use them, right? And like that. So 0, 1, 0, 2, 1 and 2, 3. This will be combination. This already is over. Next 1, 2, 2, 2, 3, 2, 4, 2. So all it will be representing A's count. So suppose if I take there is no combination between connection between 1011 and 2. So which will represent the number of B's. Once it is B has counted as the 2, third B has come back to the same process, come back to the 10, right? So on B and this will gives you complete DFA for divisible by 5, number of A's divisible by 5 and number of B's divisible by 3. If we understand this concept, so I made it easy for you people. How do you make the pair of state? How to take the remainder is convert into the state of DFA. I hope you found this explanation helpful. Do favor me. Hit the like button, subscribe for more Automata tutorials, and comment below if you want me to explain more DFA and NFA problems. Thank you for watching. I'll see you in the next video. Thank you.